Good day, everyone! Welcome to another episode here in Valenzuela Live Mathematics 8. I am Ms. Beverly Abulak from Vicente P. Trinidad National High School, and I will be your math teacher for today. Come in, let us explore and discover the beauty of mathematics. We are now on the 6th week of the 3rd quarter, and together, we will learn about proving the congruence of two triangles. And for today's lesson, you should be able to identify conditions for triangle congruence, use triangle congruence postulates and theorems to prove that two triangles are congruent, use two-column proof in proving that two triangles are congruent, and recognize real-life applications of congruent triangles. Are you ready? A new three-park site will be built in your school, in which it will contain 3 triangular gardens. The design for the three-park is shown on the graphing paper. Does the garden BRY and WET have the same sizes and shapes? Are they congruent? If yes, how can we prove that the two triangles are congruent? How can we apply the triangle congruence theorem to prove that the two triangles are congruent? Let us first review the previous topic by answering the activity in the next slide. Enjoy! Activity number 1. Identify my postulate. So the directions have to identify the corresponding triangle congruence postulate of the given figures. Choose the appropriate reactions for each figure. So students, you just have to press the like react button if the given figure shows the angle, side, angle congruence postulate. Heart react button if it shows side, angle, side congruence postulate. And wow react button if the figure shows side, side, side congruence postulate. And you have 5 seconds to answer each item. Are you ready? Then let's begin. Number 1. What reaction suits the given figure? Time's up. The answer is side, side, side congruence postulate. Therefore, you should be able to press the wow react button. Number 2. What do you think is the correct answer? Very good. The answer is side, angle, side congruence postulate. Therefore, you should be able to press the heart react button. Number 3. What is your pick? Is it a heart reaction, wow, or like reaction? Time's up. The answer is angle, side, angle congruence postulate. So therefore, you should be able to press the like react button. Number 4. What do you think is the correct answer, class? Very good. The answer is side, side, side congruence postulate. So therefore, you should be able to press the wow react button. Number 5. What do you think is the correct answer? Alright. the answer is side-angle-side congruence postulate. So therefore, you should be able to press the heart react button. Very good, students. I hope you got all the correct answers. Now, how do you find the activity? Do you find it difficult to identify what congruence postulate is illustrated in each figure? What is your basis in determining which congruence postulate is illustrated in each given figure? In the previous lesson, you learned that triangles are congruent if they have exactly the same shape and size. Specifically, two triangles are congruent if and only if their vertices can be made to coincide so that corresponding sides are congruent and the corresponding angles are congruent. So, however, in certain cases, if the three pairs of corresponding parts are congruent, then it is sufficient to prove that two triangles are congruent. Now, various definitions, theorems, and postulates will be used to prove if two triangles are congruent. So that's why you have to be familiarized with it. Definition of vertical angles. So the angles opposite to each other when two lines cross, they are always equal. So in this example, angle A and angle B are vertical angles. So vertical refers to the vertex where they cross, not the up and down. So they are also called vertically opposite angles. Next, we have the vertical angle theorem. It states that the vertical angles are congruent. Next, we have the reflexive property. It states that any segment or angle is always congruent to itself. If angle A is an angle, then angle A is congruent to angle A. If a line segment AB, then line segment AB is congruent to a line segment AB. If O is a shape, then O is congruent to O. If a side is shared between triangles, then the reflexive property is needed to demonstrate the sides congruent with itself. Now, let us now recall the conditions under which two triangles are congruent. Two angles, angle A and angle B, are congruent, denoted by angle A is congruent to angle B if and only if their measures are equal. Examples, the measure of angle A is equal to the measure of angle B. So, two segments DE and FG are congruent, denoted by the line segment DE is congruent to the line segment FG, if and only if their measures are equal. Next, we have the definition of congruent triangles. So, two triangles are said to be congruent if their corresponding parts are congruent. Now, we have the triangle congruence postulate theorem. Number one, we have the SAS, or the side-angle-side congruence postulate. If two sides in an included angle of one triangle are congruent to the corresponding two sides and the included angle of another triangle, then the triangles are congruent. Next, we have the ASA, or the angle side, the angle congruence postulate. If two angles and the included side of the one triangle are congruent to the corresponding two angles and an included side of another triangle, then the triangles are congruent. Next, we have the SSS congruence postulate, or side-side-side congruence postulate. So if three sides of one triangle congruent to the corresponding three sides of another triangle, then the triangles are congruent. So from this congruence postulates mentioned, other theorems can be deduced. Of course, if you suppose you are given the measures of two angles and a non-included side, are this information sufficient to prove the congruence of two triangles? So we have the AAS, angle side congruence theorem. It states that if two angles and the non-included side of one triangle are congruent respectively to the angles and the non-included side of another triangle, then the two triangles are congruent. So as you can see in the figure 1, given that the triangle BOG is congruent to triangle CAT, angle D is congruent to angle C. Angle G is congruent to angle T as marked. So while segment DO is congruent to segment CA, tells the congruence of the non-included sides. Now, the proof of this theorem will be presented later. Let us first identify the parts of a right triangle. So a right triangle is a triangle that has one right angle. So we know that the triangle has 3 sides. So notice in the picture that there is a side across from the right angle. So this side is called the hypotenuse of the right triangle. Then the other 2 sides are called the legs. HYA congruence theorem or hypotenuse acute angle. If the hypotenuse and an acute angle of one right triangle are congruent to the corresponding hypotenuse and an acute angle of another right triangle, then the triangles are congruent. So this theorem can be applied to right triangles only. So figure 2 at the right shows 2 right triangles, triangle RGA and triangle MSA. The hypotenuse AR and the hypotenuse AM are congruent as marked. Triangle RGA, angle RGA rather, and the angle MSA are congruent because they are right angles. Then angle GAR and the angle SAM are acute angles, and angle GAR is congruent to angle SAM because they are vertical angles. So using these congruent parts, the 2 right triangles are congruent by HYA congruence theorem. Another one, we have the HYL congruence theorem or the hypotenuse leg congruence theorem. Here, the hypotenuse and the leg of one right triangle are congruent to the corresponding hypotenuse and a leg of another triangle, then the triangles are congruent. Again, this theorem can be applied to right triangles only. So as shown in figure 3 at the right, triangle USB is congruent to triangle ARC. Now, segment US and the line segment AR are the legs. And the segment UB and the segment AC are the hypotenuses of the given triangles. So segment US is congruent to segment AR. And segment UB is congruent to segment AC as marked. While angle S is congruent to angle R because both are right angles. So the 2 right triangles are congruent by HYL congruence theorem. Next one, we have the LA congruence theorem or the leg acute angle congruence theorem. If a leg and an acute angle of one right triangle are congruent to a leg on an acute angle of another triangle, then the triangles are congruent. In the 2 right triangles in figure 4, segment GU and segment RA are the congruent legs as marked, and the angle M and the angle P are congruent acute angles as marked. And angle G is congruent to angle R because both are right angles. Hence, the segment GU and the angle M are congruent respectively to segment RA and angle P. So the two right triangles are congruent by LA congruence theorem. The proof of this theorem again will be shown later on. Next, we have the LL congruence theorem. If the legs of one right triangle are congruent to the legs of another right triangle, then the triangles are congruent. And the right triangles in figure 5 at the right, segment AB and the segment OC are the longer legs, while segment BG and segment CP are the shorter legs of the two triangles. Segment AB is congruent to segment OC, and segment BG is congruent to segment CP, as marked. Hence, we can conclude that the two legs of triangle BAG are congruent to the two legs of triangle COP. So, triangle BAG is congruent to triangle COP by LL congruence theorem. Now, how do we prove that the two triangles are congruent? How do we prove the different triangle congruence theorem? Remember, in proving that the two triangles are congruent, we can prove in a paragraph form or using the two-column proof. So when you say two-column proof, it is a formal type of proof in geometry in which the known or the derived statements are written in the left column, while the reason for each derived statement is written on the right column. Here are the steps in proving that two triangles are congruent. For step 1, you have to identify what the given are and what is to be proved. Mark the given information on the diagram. Step 2, you have to identify the congruence theorem to be used and the additional information needed and why. Then last step, step 3, you have to write down the statements and the reasons in a two-column proof. Make sure the last statement contains what should be proved. Now, let us apply the congruence postulates and the theorems in proving congruent triangles using the illustrative examples. Let's go. For example number 1, you have to prove that triangle RAW is congruent to triangle RSD. In figure 6, now, for step 1, you have to identify what the given are and what is to be proved. Now, our given here is segment AR is congruent to segment SR, segment WR is congruent to segment BR. Now, we have to prove that the triangle RAW is congruent to triangle RSD. Step 2, we have to identify the congruence theorem to be used and the additional information needed and why. So as you can see, angle WRA, look at the figure, angle WRA and angle BRS are vertical angles. So they are congruent by vertical angle theorem. So hence, SAS congruence postulates can be used to prove triangle RAW is congruent to triangle RSD. Step 3. Write down the statements and the reason in a two-column proof. Make sure the last statements contains what should be proved. So this is our two-column proof. For our first statement, we have to write the given. The segment AR is congruent to segment SR, and segment WR is congruent to segment BR. So the reason is the given. Now, as you can see, based on our given, we have to use all our knowledge about the definitions, theorems, and all the postulates we have to do. Okay, so number 2, As you can see, angle WRA and angle DRS are vertical angles as shown on the given figure. So as the reason, by the definition of vertical angles, we can say angle WRA and angle DRS are vertical angles. Next, angle WRA is congruent to angle DRS. So we can say that by the vertical angle theorem. Now, from that, triangle RAW is congruent to triangle RSD by the SAS congruence postulate. Now, we were able to show the congruence of the two triangles using SAS congruence postulate. Example number 2, based on figure 7 at the right, prove that triangle REC is congruent to triangle CAR. So our step 1, you have to identify what the given are and what is to be proved. So given the segment RE is congruent to segment CA, segment EC is congruent to AR. Segment AR is marked on the figure 7. Okay, we have to prove triangle REC is congruent to triangle CAR. So for our step 2, you have to identify the congruence theorem to be used and the additional information needed and why. So as you can see on the figure 7, segment CR is the common side. Okay, the common side of triangle REC and the triangle CAR. So by reflexive property, hence, SSS postulate can be used to prove triangle REC is congruent to triangle CAR because each of the 3 sides of triangle REC is congruent respectively to the 3 sides of triangle CAR. So for our step 3, we have to write down the statement and the reason in a 2-column proof. Make sure the last statement contains what should be proved. Again, we have to prove triangle REC is congruent to triangle CAR. So for our first statement, you have to write down the given. The given is segment RE is congruent to segment CA, segment EC is congruent to segment AR. What is our reason? Given. The next one, as you can see, these 2 triangles, they shared a common side. Is it correct? Yes, since they shared a common side, we can say that side CR is congruent to side CR. So what is the reason? The reflexive property. Next, we have, so therefore, triangle REC is congruent to triangle CAR by SSS congruence postulate. Okay, for example number 3, in the figure 8, prove that triangle DOG is congruent to triangle CAT. So for step 1, identify what the given are and what is to be proved. So our given is segment DO is congruent to segment CA. Angle D is congruent to angle C. Angle G is congruent to angle T, as marked on the figure 8. So we have to prove triangle DOG is congruent to triangle CAT. The next step, again, we have to identify the congruence theorem to be used and the additional information needed and why. Now, since it is given that angle D is congruent to angle C, angle G is congruent to angle T, then by angle sum theorem, angle O is congruent to angle A. What does it mean when we say angle sum theorem? Angle sum theorem states that the sum of the measures of the angle of a triangle is 180 degrees. So because the 2 corresponding pairs of angles are already congruent, so the third pair of angles are also congruent. So thus, the two triangles can be proven either by ASA congruence postulate or by AAS congruence theorem. Okay, for the last step, we have to write down the statement. Rather, step 3, write down the statements and the reasons in a 2-column proof. Make sure the last statement contains what should be proved. Now, the first statement, we have to write down the given. So, segment DO is congruent to segment CA. Angle D is congruent to angle C. Angle G is congruent to angle B. So, what is the reason? The given. Next, from that, the angle DOG is congruent to angle CAT by AAS congruence theorem. So, for example number 4, in the right triangle, in figure 9, as you can see, prove that triangle ARG is congruent to triangle AMS. So for step 1, you have to identify what the given are and what is to be proved. So given the segment RA is congruent to segment MA, angle D and the angle S are the right angle. So prove that triangle ARG is congruent to triangle AMS. So for step 2, you have to identify the congruence theorem to be used and the additional information needed and why. So as you can see, since the segment RM intersects the segment GS, vertical angles are formed. And vertical angles are congruent, thus AAS congruence theorem can be used. So to prove triangle ARG is congruent to triangle AMS. Now, this is our 2-column proof on the first statement. Number 1, we have segment RA is congruent to segment MA. What is the reason? It is the given. Next, angle G and angle S are right angles. What is the reason? The given. Now, as you can see on the figure 9, we have the angle G and angle S. So we can assume we can say that angle G and angle S is congruent. Why? Because of the right angle theorem. Angle G is congruent to angle S. Mark on the figure 9. Next, as you can see, angle RAG and angle MAS are vertical angles. So the reason is by the definition of vertical angles. Hence, angle RAG, because they are vertical angles, angle RAG and angle MAS are congruent. What is the reason? The vertical angle theorem. Therefore, triangle ARG is congruent to triangle AMS by AAS congruence theorem. Now, let us try to explore examples of triangle congruence in the real world and prove that these triangles are congruent. Example number 5. Shapes formed by the ribs, stretchers, and shaft are congruent whether an umbrella is open or closed. So prove that the triangles formed by the shaft and the ribs are congruent. Again, for step 1, we have to identify what the given are and what is to be proved. So as you can see on the figure, the given, the quadrilateral RAIN or RAIN is a parallelogram. And the segment AN is a diagonal. Prove that triangle ARN is congruent to triangle NIA. So for step 2, we have to identify the congruence theorem to be used and the additional information needed and why. Now, the congruence between triangle ARN and the triangle NIA can be proven by SSS ASA, and SAS congruence postulates. Okay, so let's have the case number 1. So for our first statement, you have to state the given. Quadrilateral RAIN is a parallelogram. What is the reason? This is the given. The second one, segment AN is a diagonal. This is also our given. Just write it on the reason. The third one, as you can see, segment AR is congruent to segment NI, and segment RN is congruent to segment IA. Okay? We can say that using the opposite side of our parallelogram are congruent. Again, what is the reason? The opposite sides of the parallelogram are congruent, hence the segment AR is congruent to segment NI, and segment RN is congruent to segment IA. The fourth one, as you can see, segment AN is congruent to segment AN by the reflexive property. Therefore, triangle ARN is congruent to triangle NIA using the SSS congruence postulate. Next one, the case 2. Again, for the statements, we have to write down all the given. Quadrilateral RAIN is a parallelogram. Segment AN is a diagonal. They are the reasons. Now, on the figure, as you can see, angle R is congruent to angle I by the opposite angles of a parallelogram are congruent. The next one, from that, segment AR is congruent to segment NI, and segment RN is congruent to segment A. So what is the reason? By the opposite sides of a parallelogram are congruent. Hence, we can prove that triangle ARN is congruent to triangle NIA by SAS congruence postulate. So let's have the case number 3. So as you can see, we have to write all the given. Quadrilateral RAIN is a parallelogram. What is the reason? It is the given. Segment AN is a diagonal. What is the reason? It is a given. So as you can see, segment AR is parallel to segment NI, and segment RN is parallel to segment IA. Now, what is the reason? By the opposite sides of a parallelogram are parallel. Again, we can say that the opposite sides of our parallelogram are parallel. So therefore, segment AR is parallel to segment NI, and segment RN is parallel to segment IA. Next, as you can see, angle is congruent to angle 4, and angle 2 is congruent to angle 3, as you can see on the given figure. Now, what is the reason? Alternate interior angles are congruent if parallel lines are cut by a transversal. So now, since they share the same side, segment AN is congruent to segment AN by the reflexive property. So therefore, triangle ARN is congruent to triangle NIA by the ASA congruence postulate. Example number 6. Determine if triangles are congruent. So you have to consider the figure at the right. The diagonals of the tower form triangles. Consider triangle AEC and triangle FED as illustrated. Step 1, you have to identify what the given are and what is to be proved. Given the quadrilateral ADFC is an isosceles trapezoid, and the angle EAC is congruent to angle EFD. Prove that triangle AEC is congruent to triangle FED. Step 2, you have to identify the congruence theorem to be used and the additional information needed and why. Now, on our two-column proof, as you can see, angle EAC is congruent to angle EFD, as you can see on the given figure. That is the given congruent angles as our reason. Now, angle ECA is congruent to angle EDF. Now, what is the reason? The congruent, they are congruent because of the alternate interior angles. Angle AEC is congruent to angle FED. They are congruent again by the vertical angle theorem. Now from that, so you can see segment AC and the segment BF are not congruent. Why? Because the reason is that the parallel sides of a trapezoid are not congruent. Okay? Next, angle segment AE rather, and segment EF on the given figure are not congruent. Same as segment CE and segment ED are not congruent. The reason? Diagonals of an isosceles trapezoid do not bisect each other. So therefore, triangle AEC and the triangle DEF are not congruent. As you notice that the three pairs of corresponding angles of the two triangles are congruent, however, this fact will not be sufficient to prove triangle congruence. Hence, again, triangle AEC and the triangle are not congruent. Now, the angle combination shows that the two triangles may have the same shape but different sizes. So in the figure, on the previous slide, the triangle AEC and the triangle FED have the corresponding angles congruent, but their sizes are not the same. Therefore, we conclude that triangle AEC and the triangle FED are not congruent. How do we prove that the two triangles are congruent? You have to be familiarized with the various definitions, theorems, and postulates that use in proving congruence of a triangle. Again, here are the steps. Step 1, identify what the given are and what is to be proved. You have to mark the given information on the diagram. Step 2, you have to identify the congruence theorem to be used and the additional information needed and why. And step 3, you have to write down the statement and the reasons in the two-column proof. Make sure that the last statement contains what should be proved. Let's have another activity entitled Fill Me Up. Directions. Fill in the statements or reasons in the two-column proof below. You have 15 seconds to answer each given problem. Number 1, the given is CA bisects angle DAB and AD is congruent to AB. So you have to prove triangle ABC is congruent to triangle ADC. 15 seconds timer starts now. Time's up. Okay, let's answer. As you can see on number 1, our given is AD is congruent to AB. What is the reason? Again, it is the given. The second statement tells us CA bisects angle DAB. Again, it is also our given. It is the reason. The third one, as you can see, angle CAB is congruent to angle CAD. Now, we can say this on the definition of the angle bisector. Again, based on the definition of an angle bisector, angle CAB is congruent to angle CAB, as shown in the given figure. The fourth one, as you can see on the figure that they shared as the same side, which is the segment AC. Segment AC is congruent to segment AC. So what is the reason? By the reflexive property of congruence. For the fifth one, triangle ACD is congruent to triangle BCD. So here we conclude that the two triangles are congruent by the SAS congruence postulate. Number 2, given AB is parallel to CD, angle ADB is congruent to angle CDB. You have to prove that triangle ABC is congruent to triangle ABC. Timer starts now. Time's up. Okay, let's reveal the answer. So as you can see, for number 2, what is the reason as we write that angle ADB is congruent to angle CDB? Again, this is our given. Next, the third one, angle ABD is congruent to angle CDB based on the alternate interior angle as our reason. Again, alternate interior angles, we can say that angle ABD is congruent to angle CDB. Now, by the reflexive property of congruence, as you can see, both triangles share the same side, which is the segment DB. So, line segment DB is congruent to line segment DB by the reflexive property of congruence. So, therefore, triangle ABC is congruent to triangle ADC. Triangle BCD by the ASA congruence postulate. I hope you've got the correct answer, students. Now, let's have our question and answer. We gathered some questions from our Valenzuela Live students a while ago, and here it is. Ma'am, are the congruence theorems applicable to 3 triangles? The answer is yes. We can have the 3 triangles, but we can only prove 2 at a time. Then we will apply the transitive property of triangle congruence. I hope I can answer your question. The next one is, ma'am, is it possible to apply the congruence theorems between 1 larger triangle and 1 smaller triangle? The answer is no. Again, when we say congruent triangles, they must be the same size and the same shapes. Now, for your homework, just take a screenshot or make a copy of your homework that will be flashed on the screen. You have to complete the table below and answer the questions that follow. Again, this homework is located on your self-learning module number 6, page 21. Again, this is Teacher Beverly Abulak, your mathematics teacher. Thanks for watching. Until our next virtual engagement.